So, hello and welcome back. And today we are going to discuss about deep learning. We will take an overview of it, and then in the coming videos, we will see that how the different use cases of deep learning we can understand. Okay, so first of all, let us understand what is deep learning. But before that, let me give you an example so that you can understand why we need deep learning. Suppose you want to write a machine learning model which which should be able to identify whether a particular image provided to it is of dog or cat or any other animal, right? So in that case, the data set will be large and finding out the pattern will be really complex, right? So complexity will be high. It's not like you can write simple programs like you can draw a graph, and after drawing that graph you can see like the the if the nose is pointy then it's a cat, if the body is fluffy then it could be cat, otherwise it's a dog, right? So you cannot do that thing. You cannot just decide based on this that yes, when the real world data will come and my model will be able to predict it correctly. You cannot guarantee it, right? So for such kind of situations where the data is really big, because data will be big, because suppose for example if you are training your model with the help of the image of the cat, so in that case the image of the cat could be, it could be sitting in front of you. The image could be the back of the cat. The image could be the side face of the cat. The image could be something like some cat trying to uh, steal something from the fridge, like the milk. So something like that, if something comes up in front of you, and if you want to train your model in such a way so that it is able to identify the images, then in that case, obviously, just the simple machine learning models, the other models, the regression models, the supervised models, whatever we have studied earlier, they cannot help you. So, in such situations, what happens? What you will need? You will need another model which is known as the deep learning model, right? So, deep learning model, it works simply like our brain. Just like in our brain, we have different neurons, and each neuron sends the signal to the next neuron. There is a x axis, there is an axis using which the signals are going to the next neuron, and there is a uh, you know node from where the next neuron gets the signal, receives the signal, right? Similarly, in case of deep learning model, we mimic this behavior of human brain. For example, if you have to identify whether a cat is whether the image is of a cat, then in that case it can be divided into different layers. The identification of cat can be divided into different layers of decision. For example, first layer could decide whether the face looking like of a cat or not. Then comes the other body part, whether the body part or the ears, they are pointy enough, or the nose is pointy enough to decide whether it's a cat or dog, right? So those things will keep going on in the different layers. First layer will decide whether the face is looking like a cat or not. If it says that yes, face looks like that of a cat, then you will go to the next layer. The next layer will find out whether the other body part or the legs, they are looking like of a cat or not. When all the different layers gives you a final decision that yes, the head was like the head of a cat, right? The face was like a face of cat. The other body parts and the legs were that of like the cat. Then in that case, the final output or the final output neuron will give you the output that yes, this is a cat. So this will be the way to understand and learn the things as well. And this will be the way to predict whether the image presented to the machine is of cat or is of dog, right? So that will be the case of learning, and that will be the case of identifying or predicting in the real world, right? So this is how it works. The neural network. Deep learning is all about the neural networks. So different layers, each layer is created to decide a certain feature. I'm just giving an example in case of identifying some animal, right? So let us define the deep learning. So deep learning is a subfield of machine learning. It's a subfield of machine learning that uses multi-layered artificial neural networks to learn from vast amount of data. These networks, inspired by the human brain, consist of input, hidden, and output layers. There are some hidden layers where the decisions are taking shape, like whether this is cat or not. And the input layer is from where you pass the input, right? And the output layer from where you receive the output, right? So all this is just the mimic, just like we are mimicking the the modus operandi of our brain. So something around that the deep learning works. Then comes the data, like why the data is so complex. If you are training your model to identify whether the animal is a cat or not, then you also need to do the data augmentation. For example, you have got the image of a cat which is sitting in front of you, right? So that's not sufficient. It may be that someone in the real world will provide you a picture which is black and white, right? And you are training it with the help of the colored image. So in this case, you have to understand that you have to do the data augmentation, which means from the same image, you have to create number of images, probably thousands of images with different color shades, and they all will be same. And then you will pass that data, all those images for the training to the model. So this is called the data augmentation. So data augmentation is also the part of deep learning while you are training your machine learning model, right? Now comes the type of deep learning. I'm just giving you a basic idea. If you listen to me carefully, you will be able to understand what is deep learning, right? And then in the next video, we are going to obviously discuss like how it works. Then comes the types of deep learning. First is convolutional neural network. What is it? Convolutional neural networks, these are a special type of neural networks, and for these neural networks, to implement these neural networks in your machine learning program, in your uh, you know uh, in your model, which is the deep learning model, certain libraries have been provided by the Python. Right? So those Python libraries you can use, right? So these libraries are helpful to create a specific type of neural network where you will be training the model to identify some image. So it works on some grid-like data, such as image. What is an image? Image you can, just these are just the set of pixels, and each pixel you can understand as arranged in a matrix, right? So that matrix-like structure, wherever that matrix-like structure is there to train your model, then in that case this will be the convolutional neural network where it will be able to help you. This makes this makes them highly effective for tasks like image classification, object detection, and facial recognition, as they can capture local patterns and relationship within the code. So you don't have to train it or write the if else code. The convolutional neural network, they are like the unsupervised learning models. They try to find out the relationship or the pattern themselves, right? So this is how the convolutional neural network works. Then comes the recurrent neural networks. They are useful. These are the special type of neural network where you can handle such data which is sequential data, such as the text, speech, or time series. The time series means with the time how the data performed, how the for example, how the sale was done for a particular organization over the 100, over the 20 years, like not 100 years, over the 20 years, how the data proceeds with respect to the sales in each month, over the years, or over the quarter. So for that kind of data, if you have to use that kind of data to make a prediction model, right? So in that case, a specific neural network is used, which is known as the recurrent neural network. So recurrent neural networks are designed to handle sequential data such as text, speech, or time series. They have a form of memory that allows them to use information from previous steps in the sequence to influence the current output. This architecture is well suited for applications like language modeling, machine translation, and speech recognition. So you can understand. So recurrent neural network is a different kind of neural network. It is neural network, but separate libraries. From the same library, separate functions you will use. A different kind of neural network you will create if you are getting this kind of data to train and to make it, you know, enable it to predict such kind of things. Then comes the generative adversarial networks. What are they? So these consist of two competing neural networks. There are two competing neural networks. One is the generator and one is the comparator, right? For example, the generator creates new synthetic data, for example, the image, while the discriminator tries to distinguish the real data from the fake data, right? Generated by the generator. This adversarial process forces the generator to produce increasingly realistic and high quality outputs. Right? So, what happens? That you are generating some new images. So, you can understand that comparator and generator, with the help of these two recurrent neural networks, these two neural networks, which are known as the generative adversarial networks, what we are doing, we are creating two neural networks. One neural network is acting like a teacher, and the other neural network is acting like the student. And this teacher is an art teacher. This student is an art student. He is creating some kind of images. This student is creating some kind of images. And the teacher, who is the comparator, student is the generator, and the teacher is the comparator. Whatever student is generating, the teacher is comparing whether the image that I asked him to generate, whether he is able to generate it properly or not. If the teacher has asked the student to create a cat, to just draw a cat. If the student is not able to draw a cat properly, then teacher will tell that no, it is not looking like that, you know, good, right? It's not that good. You need to do some changes. So this will give the feedback. So in the GANs, the generative adversarial networks, there are two networks, two neural networks. One is training the other. So this way, we can create that kind of machine learning model which is able to generate the perfect images for you, right? Learning from the existing images and then generating it for you, right? So these are specifically used for that case. So it can produce increasingly realistic and high quality outputs. So GAN are used to teach the model, to enable the model to generate the high quality images, which looks more realistic, right? Then comes the transformer. What are the transformers? These are the powerful and modern architecture that relies on a mechanism called self-attention. This allows them to weight the importance of different parts of the input sequence. They are giving the self-attention. They are learning themselves. They are giving the attention like which part is really useful for me, right? For example, if I say I have to decide whether this is a cat or not. So just like looking like the cat's tail, maybe not be that important for me to identify. So, in the transformer models, it is decided which part of the data is useful for me or not. A particular portion of the data, whatever has been provided, like I have got the data of tail, I have got the data of the legs, I have got the data of the middle portion of the body, and I have got the data of the face of the animal, right? So, which part is important for me? Most important for me. So, that kind of decisions are made by these transformer kind of models, right? So, these are this allow them to weigh the importance of different parts of the input sequence, enabling them to process data in parallel and capture long range dependencies more efficiently than RNNs. So recurrent neural network, where the recurrent neural networks cannot be that useful, in that case this transformer can be useful. And whatever use cases are there for recurrent neural networks, you can understand that they are also the same for transformers, but transformers will help to refine it more in terms of deciding which data is useful for me to train the model, to train myself. The model will be training itself, right? So there the transformers are useful. They have become the standard for natural language processing tasks. So transformers, so here it has been written that the transformers have become the standards now. If you have to do the natural language processing task, then in that case, you are not using these days the learning programmers or the deep learning programmers. They are not using RNNs. Whenever it comes to natural language processing, they are using the transformers. This is what has been mentioned here. Right? So I hope you must have understood what has been done here and what is deep learning. Right? So we'll meet in the next video. Till then, have a nice day and bye bye. And please like this video and share this video with your friends and subscribe my channel. Thank you. Have a nice day and bye bye.